Hello, I'm Matthew Davis with Kingsman Homes, and I'm here with engineer for this structure, Matt with Anvil Engineering. Matt, would you like to tell us a little bit about yourself and your company?
Sure, yeah. So my name is Matt Gray. I run Anvil Engineering. We're a small structural engineering firm. We do 100% residential work. We work mostly for custom home builders like Matthew here. We also work for architects and sometimes work directly for homeowners. But basically what we do is we produce structural plans for new custom homes. So we design all the wood framing, size all the beams, and also design the foundation. And then we produce a set of structural blueprints that can be used to do a takeoff on the structure of the house and then ultimately build the house. We're based in Katy, Texas.
That's good for right now. So, whenever you're designing a structure, what are some of the things that you're looking for whenever you receive that set of plans? Is there important information that you need from things like soils testing, and how important are those things?
For sure, yeah. So we, before we start a project, we need a few things. We need obviously a signed contract. We need a soil report, and we need the architectural drawings. So we need, a PDF version, and we typically need the AutoCAD file as well.
Yeah.
Once we have all that, we can really get going on the structural plans.
Yeah. So whenever you first receive that set of plans, what are some of the things that jump out to you or triggers for you, other than the inputs that you receive in terms of information? So what are some of the things that jump out to you as an engineer? You're like, I need to make sure I pay attention to these sorts of features and details.
So one of the things I look at first, I'll look at the exterior elevations of the house, and I look at what kind of roof covering it has. Most houses have, use a composition shingle roof. Mm-hmm. Sometimes there's a standing seam metal roof. Sometimes there's a clay tile roof. If there's a tile roof, a heavy tile roof, that's going to impact, what we use for rafters.
Okay.
It's going to impact the size of beams and maybe some joists. So that's one of the first things I look for. So the soil report is really important. The greater Houston area has a lot of, highly expansive soils. Mm-hmm. And that soil report gives me as an engineer the information I need to design a slab typically.
So just to cut you off, sorry.
Sure.
When you say highly expensive soil, what type of soil are we talking about? Because here, for instance, I think this map of soils says that we have 60 feet of sand. But so when you say highly expensive soils, what does that mean?
It's clay soil.
Okay.
And not all clay is created equal.
Yeah.
There's some types of clay that are much more expansive than others.
Okay.
But it's the job of the geotechnical engineer who writes the soil report to come out and take some soil samples and then basically write up a report that kind of characterizes the soil on the lot.
Gotcha.
And they'll give us, information like bearing capacity. They'll give us, especially if it's a post-tension slab that we're going to design, there's some design parameters that they provide to us. If we're going to be using drilled piers under the slab, they'll tell us, how deep they need to be, things like that. So every once in a while, I'll have a client that doesn't want to give a soil report. And it's just, as an engineer, it's hard to design a foundation without one.
Yeah.
And in most cases, I won't even do that.
Yeah, and then as a builder, it's impossible to bid one without it. So you're bidding and designing half the picture of the most important part of the entire structure.
That's right.
Sure, you know what's going on top, but you don't know what's going on top is going on top of.
Right.
So it's impossible really to truly design and build something that you can stand behind without something like a soil report.
The soil report, I think most of them go for $1,000 to $2,000 typically.
Yeah, that's correct.
Really, really important. Money well spent. I mean, the foundation is it's the foundation of the home. It's going to support all the nice countertops, all the nice finishes. If we don't get that right, homeowners are going to be unhappy.
Correct.
So really, really, really important to get a soil report. There's lots of different geotechs all around the Houston area. We see reports from a lot of different geotechs.
On this structure, we did do a soils test, and then he also engineered the foundation, and we did a post-tension slab. However, we still have some cracking in it. So Matt, would you like to just kind of explain and elaborate a little bit what this cracking is?
Yeah, so all concrete cracks, particularly with post-tension slabs, you're more likely to get some cracking like this. These are called shrinkage cracks. As concrete cures, water evaporates and the concrete will shrink some, and you can develop cracks like this. Shrinkage cracks are not structurally significant, but you are more likely to get them with a post-tension slab. And the reason is because after we pour concrete, we wait typically a week or two before we tension the cables. So the concrete's sitting there basically unreinforced for a week or two.
Yeah.
So that's when a lot of these cracks, shrinkage cracks, will develop. After we tension the cables, typically these cracks tighten up a lot.
Yeah, which they have.
Yeah.
This is what I consider very minor.
Very minor. But I do have clients that see this sometimes and they're concerned, and rightly so. But this is very normal, especially in the Houston area, especially during hot weather.
Yeah. All right, so moving on from the foundation to the framing. So on this house, one of the things that we expect was to do advanced framing. Advanced framing with 2x6 studs on 24-inch centers. My reasoning behind doing that is because I'm trying to have as much insulation as possible in the net of that wall. Could you highlight or elaborate a little bit on the difference between doing 24-inch centers and 16-inch conventional centers?
Yeah, so 2x6s at 24 inches on center is perfectly fine. Obviously, everything has a limit, so you can't. You wouldn't have a 20-foot wall, constructed like that. But most custom homes, like a 10-foot ceiling or whatever, that's fine. It does leave you a lot more room for insulation, which particularly here in Texas is a big concern for people.
Yeah.
And I've read that just a typical wood frame wall 2x6s at 24 inches on center is actually going to be less lumber.
Correct.
Than a typical 2x4 wall at 16 inches on center.
Yeah, and one of the reasons why you would want less lumber is one, cost, spending less money on the lumber itself, and then two, the R value of the wall as a total, because wood has an R value of more or less 1 per inch. So everywhere you have a stud, you have essentially R 5.5, where you're supposed to be getting R 13 at the minimum here in this area. So the less lumber you have in that wall collectively, the more insulation you have, the better performing overall in terms of energy efficiency, heat gain and loss that wall gets. Moving on from the 24-inch centers and to some of the other details of advanced framing, such as ladder blocking like we have here. Some people may see this corner and say, it's not strong enough. What is your opinion on that as an engineer?
Yeah, so there's, with advanced framing, there's situations and locations in a house where it's appropriate.
Yeah.
There's also some locations and situations where we can't install an advanced framing detail. So particularly like in a high wind area, where we have a lot of hold downs that have to be nailed to a double stud. Obviously we're gonna have a double stud there, we have to. So you can't really do like a California corner there.
Yeah, so like what, in advanced framing, and essentially for Energy Star rating purposes, you have to have an insulated header. So what do we spec here for the header?
Yeah, so here, this looks like a triple 2x6 header. And we've got some insulation foam board in between the 3 plies. Typically, conventional framing, we would have had plywood where you have the foam board. As an engineer, I don't rely on the plywood for strength.
Gotcha.
So I rely on the 2x6s. So again, I have no issue with the foam board being used between the 3 plies. And this is one of the details that we specify on our drawings.
All right, so one thing that I've noticed kind of being a trend just from the builder's perspective over the years or here recently is like wind load and wind lift and uplift, and how that number design that we're having to build to has been getting stricter and stricter and increasing. So first of all, what does that mean in terms of wind uplift, and what are you designing for whenever you're trying to combat those things?
Yeah, so as you know, every once in a while they come out and they revise the building code.
Okay.
And things seem to be trending in a direction where they're requiring more and more from engineers and builders. So about, I think it was 10 years ago or so, they revised some of the wind contour maps, so that areas that were north of Houston kind of got a new design wind speed that had to be designed for. And with the weather we've had this year, I expect that's just going to continue, and it's just those contours are going to be continuing to the north.
Yeah.
So what used to not be a high wind area probably someday will be a, you know, more of a high wind area, kind of like the city of Houston.
Yeah.
But as you can imagine, that when the wind blows on a house or on anything, it's going to try and turn over.
Yeah.
And so you know, if the wind blows this way, you're going to get uplift on this side. So that's where you'll see lots of like embedded hold downs, the metal straps that are embedded in the concrete
Yeah.
and then
J-bolts.
nailed to the frame. Yeah, anchor bolts, things like that. So those things are designed to help hold the house on the foundation.
Mm-hmm. So in terms of like structural sheathing, what does that mean when we're trying to hold the overall structure together from getting twisted and toppled over? Especially here as of recently, we've had numerous structures across the greater Houston area essentially twist and fall down just from minor to significant wind events.
Right. Yeah, I know of several houses this year with these wind events that we've had that they weren't completed houses, thankfully, but they were being framed, and they had not installed all the clips and straps and hold downs and the sheathing around the perimeter of the house.
Mm-hmm.
So those houses really had very little lateral resistance to the wind load.
Yeah.
And so I've seen a lot of houses that are shifted and twisted and things like that. Some of them had to be torn down. But this sheathing, this structural sheathing around the perimeter, really makes the house stiff, like a stiff box.
Yeah.
This is zip. I see this a lot with custom home builders in the greater Houston area. Also see a lot of just regular old OSB.
OSB with tie deck.
See a little bit of plywood, but typically I see OSB. But all of our plans will have this type of product specified on it.
Yeah.
I think this is the way to build a house, is to wrap it in really good
some sort of
sheathing.
solid sheathing.
Yes.
So not necessarily using something like, if you could bend it with your hands or stab a hole through it with a knife, then it's probably not doing much for you in terms of structural.
Right, and there's some other products that are not wood based. They're more of a composite type material. They're a lot thinner than this stuff. And some builders will use that. I just never see it, and it's rated to be used similar to plywood or OSB. I just rarely see it installed correctly.
Correct.
So installation, nail pattern, not overdriving nails, things like that, super important.
Yeah.
If you don't install it correctly, you're not going to get the resistance that it's rated for.
Sure.
So.
All right, I think that's good.